Hello, so we're back, and this time we have some interesting device to repair. I mean, this I know what it is. It's a NLBA. Not sure about this, but let's read the customer email. The customer is a computer business, so the NLBA device not working. Yeah, indeed, the manufacturer, the guy which is selling the NLBA, he contacted me and he asked me if I can fix the devices, and I said, yeah, I can try. Also, my EV2400. Not sure what is this, but I think it's the same. It's a different interface which is working with NLBA. So you don't have to buy the NLBA from the NLBA guy. You can buy the device from anywhere, yeah, from a different place, a different device, and all you have to do is to download the software from NLBA, and you have a working unlocking solution. So he's saying both device files on the same way, and that's all what we have from his email. But we have the letter here, and he's saying while testing the batteries, we higher voltage than normal. And not sure what that means. High DC voltage contacted the positive terminals, causing our device to malfunction. So not sure exactly what that means. High voltage than normal. I mean, okay, so the device didn't die by the USB. I killed like 3 PL2303 interfaces. And I have chips here on the drawer, so every time, because my solder iron have different potential compared to the computer. So if the NLB is connected to the computer and I solder something on the same time because my dodgy solder iron, yeah, I will burn the interface, the USB interface. But here we have a different kind of damage. Anyway, let's have a look. Let's have a look at the NLBA. For the NLBA, I have one for spares. Yeah, I have a faulty one for spares, yeah, which need only the chip. It's all working, but need the PL chip, which I have it, but I didn't have time to fix it. And even if I fix it, already I have one here. So it's good for spares. Okay, so this is one. Let's see what it's doing. Let's plug it, or we should not plug the charger, right? We should plug the charger. Probably not. I would say let's open the box and let's check inside. Are a lot of people, they are doing only this, yeah? They are just battery repairs. And you will think, okay, this is a business actually fixing batteries. They have like a fan base. No. I spoke with a guy, yeah, yesterday. Yeah, yesterday. We don't know. We spoke about something. And he said he started this project with NLBA when he was doing business. He was selling ThinkPads, Lenovo ThinkPads, and he sold like 5,000. But he always have issue with the batteries. And that's the moment when he started this project many years ago. So yeah, there are businesses just, dealing with second-hand laptops, buying, selling, stuff like that. And yeah, they want a solution to save money from the battery. So the device is open. Okay, let's take the board out. Now we're gonna see the manufacturer design. It's a dodgy design. It's made to fail. What do you think? Let's see. I'm always judgmental when. Okay, this is a nice board. So what do we have here? We have a linear regulator. Here we have a switching power supply. Probably this is the driver. Or no, probably this is MOSFET. This is a coil. And the output voltage is regulated in PWM. This is the interface, that PL interface for the USB. Personally, I took out that thingy and I shorted. This is just a bypass protection diode, but I got pissed off and I removed it and I just shorted the pins. Then here I'm assuming this is the CPU actually. The CPU, a microcontroller. Anyway, what could fail here? Let's check the input, the output to be sure we have no short there. So plus minus, no, it's nothing shorted. Then the input diode, we have a diode. Yeah, he fit a diode on the parallel with the charging port to protect the device in case you connect. Okay, I don't think this capacitor is meant to be shorted. What do you think? 0 ohms. You can see that? Why a capacitor it will have 0 ohms? 1 second. We checked this diode and the diode was fine. Yeah, the diode is okay. You can see. It's about this protective diode. So on the charging port, we don't have a... Actually, no, sorry, it's my fault. So this is minus, both are minus, and this is plus. So plus is going to the diode, but I'm asking about this capacitor. This capacitor is shorted. I mean, it's not the capacitor shorted, but it's short on this circuit. Let's go under the microscope. Now let's have a look. I mean, how the capacitor is part of what? That's my question. Is part of this regulator? Let's check. Wait a second. That diode for me looks like it's fried. What do you think about that? Huh? What do you think about that diode? Oh, this one, 0 ohms. So I don't think the capacitor, this capacitor is shorted. I think the diode. So check here. This is the, no, probably is the output, right? So here you have a coil from here, from the plus of the diode, which is coming here. And also is coming to the diode. Okay, I'm confused. So this is no minus. It is minus. Wait a second. Okay, so we have the plus, yeah? This is plus. Coming straight to the diode and the serial mode. Yeah, it's not on the ground, it's connected on the serial mode. Even better. So the diode cannot get shorted, this one. So from the plus of the diode, we have an inductor. Then plus is coming here, and plus is coming here to this diode, and this diode is connected to minus, I'm assuming. Okay, it's a little bit confusing. Let's remove the diode with hot air or solder iron. Let's try solder iron. So, you know what? Not sure. High voltage came in from the power port or coming from the battery, because so from the battery, check here, we have ground and we have V, which is plus, right? And it's coming from a MOSFET. So not sure if the I'm not sure. Okay, let's remove the diode. Let me grab some rosin. It's interesting, you know. Only laptops. Yeah, let's fix something else. I can't. Okay, let's help the solder iron with my hot air. Oh. Yeah, we can do it, right? Yeah, we can. And the diode, it's out. Good. Let's check now. Not sure what diode it is, but the diode is dead. And the capacitor is good. Check here. So we don't have short on the capacitor. But my question is, here is ground. Is ground. Wait a second. So this is a Zener diode, probably 24 volts one, because is ground is coming to ground. You can see 0 ohms, and plus is coming to the plus of the diode. This is a Zener diode. Is doing nothing here. Wait a second. Okay, this was an easy one. So the device can work without this diode, right? Yeah. So we fix it. We spend nothing and we are charging money. Ha! What do you think about that? Huh? So what will happen now if we are coming with voltage at the power port? Plus, minus. It's working. It's taking like 30 milliamps and we have the light. Okay, you know what? You know what is the story? The story is, if we are removing a Zener diode on a customer laptop, yeah? the customer is using always the same charger. He's not trying different chargers. You know, it's always a 19 volt charger, so it's fine to remove that center diode. But these people, they are, they are trying all kind of crazy stuff. So we really have to replace that diode. Yeah, we cannot be dodgy. Yeah, I bought this a while ago, and I don't remember for what. But let me check. PJ46. You know, this is insane. I can't find this diode anywhere. Like Google, like even on my eBay purchase list. And I bought them from eBay. I remember I bought them from eBay special for this kind of stuff. For laptops, for main power rail protection. So do you think it's a center diode? If it's a center diode, for what voltage it is? So what I'm gonna do, I'm gonna lower the current, how much I can, because I don't want to burn it, yeah? Good. So we have minus and we have plus, right? And it's taking no current. Good. Let's raise the voltage to 22 volts. And nothing, it's taking no current, nothing. 24 volts. What is beeping? Oh, okay, the multimeter. Okay, the power supply. And nothing. It's doing nothing. Let's raise the voltage to 26. And nothing. Do you think they're Schottky diodes? 29. It's taking current. 1 second. It's taking current. That means it is a center diode. 31 volts. And it's taking more current. 50 milliamps, yeah. And lowering the voltage. Yeah, it's taking nothing. Yeah, I think it's 30 volts center diode. That's what I think it is. But let me know in the comments if I'm wrong. Let's apply some solder quickly. You know what? I was expecting something worse than that. But it's okay if it's simple. It's okay. If the customer is seeing the video now, he knows how to fix it in case this happen again. But let me know if it's the right diode, yeah? I mean, should be. I seen the diode taking current. And I remember when I bought them special for laptops. Because laptops are the same like NLBA. They are using 19 volts. Perfect job, right? Yeah, I know. Let's see. Let's see if it's working. So if we are connecting the power, you see, for this kind of repair, it's very important from where the high voltage came, from the battery side or from the charger, from the power port. Here, I'm pretty sure it came from the power port. Good, so we have 19 volts. Wait, we don't have current. Sorry, it's my fault. Yeah, plug in the charger and it's taking like 400 milliamps, which is bad. And this is proper hot. But we tested together and was taking no current. Yeah, we screwed it up and it's my fault. You know why it's my fault? I mean, I burned things so many times with this one mistake. You try to power up a device and you don't have enough current. Then the voltage drop, and when the voltage drop, a lot of bad things happen. I knew it, but I forgot about the current. Plugging the charge is taking 300 milliamps, and you can't even hold the finger here. That's how hot it is. Nah, you can't do it. No. Look at the thermal camera. Check with the thermal camera, just to understand how hot is this thingy. Yeah. Feels bad, man. I mean, it was ready. It was taking no current, you remember? Okay, let me find my old NLBA, the one which is not working, and I will swap the regulator. So the regulator died because not enough current, because the voltage drop probably is recorded. We can go back on the video and see. Yeah. Yeah, I burned I remember at least one laptop I burned like that. I didn't have enough current, the voltage dropped, and something was shorted on the motherboard. So a lot of current is not good, yeah, because you are on a level of protection. But less current, again, is not good. So yeah, it's kind of tricky. Okay, give me 1 minute. Okay, I found the one I have for spares. This one has the cheapest band, the interface. But this is dodgy. My one doesn't have that diode. You can see it? That band diode is not here. Ha, and it's not here also. Okay, let's remove the chip. So basically that diode, of course, it's a protective diode, so it's not mandatory. But it's good to be here, you see? Yeah. Okay, let's remove the chip. 480 degrees. What happened in my focus? Hmm? Let's try like that. Yeah, better. And the chip, it's out. And this one, it's out. Just a little bit of rosin. Good. And it is soldered properly on place. Where is that diode? Here. Let's put the diode back. And the diode, it is soldered on place. All good. Let's cool down the board. It should be working now. Hopefully. You know, this video can be a lesson. Yeah? How you can burn things with nearly no current, because the current was very low. We lowered the current to check the Zener diode, if you remember. Yeah. Yeah, this is hot. Yeah, this is decent. Let's plug the charger. Let's be sure we have enough current. So plug in the power. It's working. The fan start. Check here. We have one light here. Yeah, the fan is temperature controlled. Great. Let's plug the interface. And it's connected to the PC. I can't test it. I don't want to test it. No. No, I don't want to test it. No. No. You know what? No. No, I don't want to test it. But it's connected to the PC. That means the interface is good. Because if I connect the PC, the program will identify change of the PC, and they are recorded. Yeah, no. I believe this one is good. The fault was pretty clear. It was only the diode. This is a protective diode. It's a Zener diode, and it's working fine. Now the current is going down as the fan is stopping, and the fan stopped. Yeah, it's taking like 20 milliamps, which is fine. We have a LED here. So I believe this one, it's okay. Good. Let me put it back together. What is more important from here is you to keep in mind this. Don't play with less current. I mean, always hold, like in this case, like I'm trying to diagnose something. Yeah, just try to hold there like 500 milliamps, 1 amp, something like that. On a laptop, probably I will always keep like 2 amps. Yeah, it's very easy to be explained why this happened because a chip, yeah, that's a chip. It's not a transistor. Has a range of working voltage. Let's say from like, so this is working with 19. Let's say 5 volts to 25 or 30 volts. Then if you don't have enough current, the voltage, it will come down under 5 volts. Yeah, depends. Let's say I just give an example like 5 volts, probably it's like 10 volts or something. I don't know. It's not even point checking the chip data sheet. But you burn things by voltage, yeah? Because we didn't have current. We have nearly no current there. And the chip got burned by actually, by basically voltage. By not having enough voltage, yeah. Okay, so this one is done. Let's see this one. I never seen this interface before. I heard actually, the people can buy it. Not sure if it's cheaper compared with that one. And we have, yeah, never seen this. You seen this before? Huh? Okay, let's open. Let's have a look inside. And the interface, it's open. That's an interesting design. I mean, how does it all work? Because you need current. You have to push current if you charge the battery. You think this one is enough? Anyway, let's check with the multimeter. Let's see if we have the same problem. Yeah, we don't have a protective diode here. I think. This is a Zener diode or what it is? Let's see. So ground. I believe this is ground, right? Must be ground. Yeah, it is ground. This is output. No, this is output and it's not short. Ha. Nah, it's nothing shorted here. Let's check under the microscope. Yeah, that's a test point actually. 1 second, 1 second. Let's see what do we have here. So we have ground. This is ground. Good. Yeah, definitely is ground. Ground with input is not short. Then we have, okay, probably this is, yeah. Okay, all good. I will say let's plug the power. What power I need here? So this one is working with 5 volts. So grabbing the power supply, switching to 5 volts. Good. So plugging the charger. It's taking 1 amp. Wow. It's smoking. That's crazy. Let me bring the thermal camera. We have the thermal camera. This chip is smoking. Oh lol, it is blow up. Check there. No, I can't fix this one. Let me check online what chip it is. I found it. So check here. Integrate 4 digital control potentiometers. Configure as variable resistor. So we have clock data and we have adjustable resistors. Probably we can buy something like that. Kind of expensive, like 20 pounds. Wow. digital potentiometers. But my question is, that's the only problem? Or how this got burned? From input voltage? Because this is burned, more things are burned. Let's remove the chip. Okay, so the chip is removed. Chip position like that. Good. I mean, the device should work even without this chip. Of course, not all input output stuff it will work, but should work. Let's plug the charger. Plugging the charger is taking like 100 milliamps. Is better. And I can't see anything to get hot. I mean, the whole board is hot, but nothing in particular is getting hot. So let me plug. Yeah, we do have the light here. Let me plug the USB. It is connecting. Let me see. No, I don't want to open the software. And now we have all three lights here, which not sure what it means. USB communication and Volten. I think I'm gonna order the chip, but I have to speak with the customer first. Kind of expensive. I found with 15, 1.5. But this is Z, and my one it is ending on 27Z. And this one is TK. Not sure what TK means. But I think I'm gonna go with the cheapest one. Just leave me a comment if you have more info. But for me, it looks like this is the only problem. I'm not even sure how this is working. Let me try to find it online. No freaking way. It's not even worth it. It's like 41 pounds on Amazon. Huh? 40 on eBay? Is that cheap? Well, that sucks, you know, I'm not even making money. It's not even point. I'm paying like 20 pounds for the chip, and what I'm charging, 20 for the soldering? I mean, I can, but if I tell the customer 40 pounds, he will go to buy another one. I say, no, I'm okay, I'm gonna buy another one. Or it's not the same. Probably is the same, it's same name. Or is this one? Wait, 1 second. But this one is coming with cables. 30 pound. AliExpress, 30 pound. Yeah, it's this one. Well, I don't know what to say. Let me speak with the customer. Let me show him the video, so he can decide whatever he wants to do. Cool. Okay, so I'll stop now. I'll say thank you for watching. You know, like, subscribe if you like the video, like always, and see you on the next one. Bye. Hey, if you find my content being helpful, don't forget you can support this channel by pressing the join button, and you can get instantly access to our members only cool collection and Discord private channels for support with your repairs. Also, you can have a look on our United Kingdom eBay, where you can find some cool and unique products, United States eBay store, or our Patreon page. Thank you.